This is fine-tuning a large language model to create your own AI that is customized to your data. And this is using a retrieval augmented generation algorithm to make your own AI that is customized to your data. So obviously both are a way to leverage your data to create a custom AI. But the question is, which one should you choose? And if fine-tuning or training your large language model on your own data is the ultimate way, then why does everybody talk about RAG? They both customize models, but in totally different ways. And so what is actually happening under the hood? What does it mean to train weights? What does that mean to have a vector retrieval? What does context injection mean? And what is a similarity search? I've worked with multiple clients that have used both those approaches, and I'm not going to give you my recommendation, I'm just going to give you what happened. Fine-tuning is the most intuitive approach in theory because it consists of using your data to train a model. Basically, when you're leveraging your data to fine-tune a model, you feed your data to the large language model and it kind of tries to predict what your data is going to be without using it, of course. And then it compares what it predicted to your actual data and try to adjust the weight under the hood of the neural networks that are inside the large language models to make it so that the prediction is going to be better next time. So it keeps predicting and keeps comparing and keeps adjusting the weights in the large language model. And there is a function called the loss function. And the entire goal of that function is to measure the prediction error. And then there is a lot of mathematical things that we don't need to care about, but basically the derivative of that function is going to help adjust the weights inside the large language models. Now, of course, there are like tons and tons of mathematical equations that are happening under the hood, but really we don't need to care about that. This is enough for what we want to talk about here. Let's move on to the RAG algorithm now. Now, something that is important to understand with the RAG algorithm is that there is not going to be any loop happening with your data. It's going to be a one-way injection from the data to the prompt. Now, the question is, what data is going to be injected into the prompt? And that's what that is, the relevant data. RD. Now, how do you know that something is relevant though? Well, that all depends on the discussion we're having. Now, what does that actually mean? It means that depends on what the user is asking. So in short, the relevant data is going to get pulled from your database dynamically every time the user is going to ask something to the custom AI that you have. And the process of looking for your data and selecting the relevant data based on what the user is asking is called a similarity search. Now that you know how both of them work, let me explain the trade-offs and limitations of both of them. So let's go back to fine-tuning. So what you know now is the large language model is going to try to do its best to try to predict your data. And it's going to adjust the weights in order to do that. Let's take a real world example for this, just so you understand the problem. Let's say you have an app and you have a voice AI simulator on it. And let's pretend the goal of your app is to train people to learn a specific language, for example. If the large language model that you have on your platform is training people to get better at a specific language, and that's the goal of your app, then what you're thinking is probably, well, I have a lot of data about that because the app is actually currently training a lot of people. So maybe a good idea would be to leverage that data in order to train the large language model. Now, here's the problem though. You can do that, but what is going to end up happening is the large language model is going to try to replicate the conversation that it has already had in the past. I don't know what is going to happen if you do that, but my best guess, and you can probably guess as well, is that not much is actually going to happen. And the reason for that is it's going to predict what it has already been doing. So if this is something that you want to do, what you need to do is structure the data in a way that is not going to be just that. So that means you need to select the relevant data where the conversation is better so that the large language model is going to train in order to get better. Now that can mean that, or you would need to craft that data by yourself, right? Come up with a conversation that you judge are better than what the current platform is actually doing, and then train your large language model with that. What's the problem with that approach though? You need a lot of data. So you need roughly something like 500 examples. Of course, this is right now, so maybe in the future it's going to change, but right now that's one of the limitations. So as you can probably tell, collecting relevant data is actually one of the main problems. And we're going to run into that very same problem with the retrieval augmented generation algorithm. Now, you might think, well, the similarity search is going to take care of that, right? That's the entire point of it. Now, let's talk about that. So in case you don't know, a vector is just a bunch of numbers. That's what one vector is. Now you need to have the exact same process of vectorization being done for the user input. Let's call that vector VU for user. Why do we need to do that for the similarity search? Because we're going to compare the vectors in the database with that specific vector, the VU. Now the distance can be calculated because those are numbers, right? That's the entire point of vectorizing things. It's so that we can calculate distances. It doesn't matter really what the mathematical formula for that. What you really need to understand is just that there isn't like an easy way to do that with a sentence, right? Because the user input is going to be a sentence. Basically, that's what makes it easy to calculate distances between text. Now, the only thing that the similarity search is going to do is calculate the distances, take the smallest ones, and then add that to the prompt. So that means it's going to take the things that are the most similar to what is in your database and add that to the prompt. Now let's go back to the example where you have an app that is going to teach you a language. If when you're talking to the AI, you ask something like, what time is it? Let's assume the database is all past users' conversation with that AI. Then what's going to end up happening is the data that is relevant to time from your past conversation is going to get injected into the prompt. Obviously, that data is completely irrelevant. So what's going to end up happening is either the AI is going to ignore completely the data, which is going to be the best case scenario. Worst case scenario is it's going to confuse the AI, and the AI is actually going to use it and mislead the user. You can see the problem here. So that's why in both cases you need to be extra careful with your database. Because in the case of retrieval augmented generation, for example, the vector in the database is something that you choose. Is that going to be an entire conversation that is going to get compared with the user input? Or is that going to be just one sentence? Or is that going to be just something else? Answering those types of questions here is going to be the game. That's how you're going to be able to troubleshoot your retrieval augmented generation algorithm. So both have advantages and trade-offs. Now I'm going to give you some actionable tips from my own experience. I'm not going to be recommending you anything here. I'm just going to give you my experience and the experience that I had with all of my clients. I've never seen fine-tuning succeeding. Now let me be very clear here. That doesn't mean that it cannot work or that it hasn't worked. I'm just saying that in my experience with all of the clients that have implemented that approach, they haven't successfully used it. And obviously that depends on when you're watching the video, because maybe in the future that's going to be the standard approach. Now the reason for that is fine-tuning is a little bit of a hit or miss. I mean, if you train your AI with a database and it doesn't work, what do? Is it just going to be about like restructuring the database, or is it just going to be about adding more data? What I'm saying here is because the troubleshooting tools haven't been really developed for that approach, it makes it extremely complicated to make it work. Now, to be clear, this is my opinion, right? Like I'm just trying to explain why I think that it doesn't work. What is not my opinion though is that it rarely succeeds. Second tip, use RAG as a problem solver. Do not use RAG because you have a lot of data that you want to leverage. Oftentimes, the easiest way to create your custom AI is just to add a lot of your data directly into the prompt without being sophisticated about it. Retrieval augmented generation is a pretty sophisticated way of solving a problem. I'm not saying this is not useful. Use it if you need to, but make sure you need to. The reason for that is retrieval augmented generation is going to create a lot of other problems. I've talked about a few of them in this video, but there's a lot of other problems that might occur. Just something to keep in mind. Now, before I keep going, if you're just a beginner and you want to create a custom AI, I know that it can be tough because there is so much things on the internet and sometimes it might be very confusing on what the roadmap is. That's the reason why I created a free online course. You can click on the link in the description to get it. Now, my last tip is default to prompt engineering techniques if you can. Those are a lot less sophisticated, they're going to cause a lot less problems, and they actually work. If you don't know about them, there is a lot of things you can learn about online, and I'm going to make more videos about it. Thanks for watching. See you in the next one.